So for the last lesson for Unit 1, we're going to be solving inequalities. Your essential question is, what processes are used when solving inequalities? And just as a reminder, I have now started weaning you off, so I'm expecting that you're doing your questions and your summary on your own. I'm collecting your notes on Friday, the day of the test, so please make sure that all your notes have questions and a summary. So here we go. How do you solve an inequality? Guess what? To solve an inequality, the steps are exactly the same as solving equations. So you use inverse operations to get the variable by itself. The only thing that you have to be aware of is if you are ever multiplying or dividing by a negative number, the inequality does what?
Flips.
It flips. And that's because negative, does anybody know another word for negative? Besides subtract. Like, what does negative technically actually mean?
Less than.
How about opposite? So technically when we say something the negative, another word for negative is opposite. So the negative means that you're going in the opposite direction on the number line. Okay? So when we are dividing or multiplying by the opposite, that means that we have to take the opposite inequality sign as well. So this is probably where students, the thing that students forget the most is that when they're multiplying or dividing by a negative, because it's an inequality and negative means opposite, you have to do the opposite inequality. So you have to flip it around. Okay, so let's talk about less than and greater than first. Less than is an arrow pointing to the left. So less than goes to the left. It does not have the half of an equal sign underneath. So it's just the inequality pointing to the left. If I am saying that an inequality or a number is less than something else, when I graph it on the number line, that means that my endpoint is going to be open. So I like to think of that open endpoint kind of as a fence. So if you were building a fence around the number 3, that's saying that I can get really close to the fence, but I can't actually get inside of the fenced area. So when I'm saying, for example, that x is less than 3, that means that I can get really close to 3, but I can't actually be equal to 3. Okay? And then any of the numbers that are less than 3, I can use. So if I'm saying x is less than 3, can x be 2.9999999? Yeah, it just can't be 3. Okay? So when we're graphing it on the number line, we use the open endpoint because that's the fence around 3. All the solutions are to the left because to the left of the number line is where all the numbers that are less than 3 lie. So if I were to graph this on the number line, I would put an open endpoint at 3 and I would draw an arrow to the left because that indicates that every single value to the left of 3, and you cannot include 3, satisfies the requirement x less than 3. Okay. When we are talking about greater than means everything that is bigger than that number. So our solutions go to the right, and our arrow is pointing to the right. It also has an open endpoint because it's the same idea. You can get really, really close to that number, but you can't actually be equal to that number. So we use an open endpoint to indicate that you can't be equal to that number. In the example, x greater than 0, I would put an open endpoint at 0, indicating that I can't touch it. So it's like building a fence around 0. And then I draw an arrow to the right, which indicates every number to the right of 0 on the number line. So where the numbers are getting bigger, those numbers are bigger than 0. Okay, this should all be review for us, right? Okay. Okay. Less than or equal to is pointing to the left. And then we know that it's less than or equal to because it has half of an equal sign underneath it, right? So this part, the line underneath, is like half of an equal sign. That's really what it is. So that's why we know that it's less than or equal to. Now, when it says less than or equal to, can I be equal to the number that I am indicating? Yes. So we used a closed endpoint. The closed endpoint means that this number is actually part of the solution. Because it's less than, all the solutions go to the left. So on the number line, for the example, x less than or equal to -1, I put a closed endpoint at -1. And all the numbers that are less than -1 are going to the left. So I draw an arrow to the left. For greater than or equal to, it's very similar. So you have half your equal sign, but all the solutions are going to the right. So your arrow is pointing to the right. Same thing, we used a closed endpoint because we can be equal to that number. And in my example, x is greater than or equal to 4. I put a closed endpoint at 4, and I draw an arrow to the right because that's where all the numbers get bigger. So our first example, I have 9t plus 4t, and that's greater than 21. Now, remember, inequalities work exactly the same as equations. The only difference is that we can graph the solutions, and if there's a negative, we have to take the opposite of everything. So if this was a regular equation, what would you do first? Karina? Yeah, and that's called combining like terms. So ladies and gentlemen, 9t plus 4t gives me 13t greater than 21. We should change that, huh? Let's change it to 26. Let's just be nice for a second. Okay, so greater than 26. And then we need to get the variable by itself. So what would you do next, Kevin? Yeah, divide by 13 on both sides. So ladies and gentlemen, I get that t is greater than what? 2. Box it. And then we're going to graph it. So to graph an inequality, you draw a number line. Just as a note, on the number line, 0 does not always have to be in the middle. Okay, so that just happens to be the one that I put up here, but 0 does not always have to be in the middle. So if I was graphing t greater than 2, first I need to put an endpoint at 2. And is that endpoint going to be open or closed? It's going to be open, so we're building a fence around 2. And then it says that all my values of t have to be bigger than 2. So where do the numbers get bigger? To the left or to the right? To the right. So we draw an arrow to the right. So that means that any number that is bigger than 2, including 2.00001, is a solution. Okay, so example 2. 6n minus 1 is greater than or equal to, let's make it or equal to, 3n plus 8. So there's going to be a few more steps involved. Bless you. So when solving equations, we first said that you use distributive property or combine like terms first. Are there either of those in this problem? Is there a distributive property? Is there a combine like terms? Not technically, no. So technically there's no combine like terms because we don't have the same term on the same side. Does that make sense? So it has to be on the same side. So what we would do here is we would just start moving our terms over to the other side. So are you guys going to move 6n or are you going to move 3n? What do you think? 3n. I would move 3n because it's smaller. So subtract 3n from both sides. As a reminder, subtracting does not flip the inequality. Only multiplication and division does. So what am I left with on the left side? 3n minus 1 greater than or equal to 8. So this is how I want you to show your work. So you're writing each step. I still don't have the variable isolated. I need to get rid of that minus 1. So I'm going to add 1 to both sides. And that gives me 3n greater than or equal to 9. And then the very last thing would be what, Elijah?
Divide them.
So we get n is greater than or equal to what, ladies and gentlemen? 3. Okay, so let's graph it. I'm going to put an endpoint at 3. Is this one going to be open or closed? This one is going to be closed because I can equal 3 because I have half that equal sign underneath. And all the numbers that are greater than 3 are to the right or to the left? To the right. Beyonce did not write a song about that. But you can sing it if you want. To the right, or to the left, to the left. Oh, wait, and then I forgot to box it. So number 3, 3 times the quantity of x plus 1 minus 4x is greater than or equal to negative 5. Okay. What would you do first? Elizabeth, what would you do first?
I would distribute.
Yes, we would distribute the 3. So, ladies and gentlemen, let's distribute the 3. And on the left, that's going to give me 3x plus what? 3. Good job. Minus 4x is greater than or equal to negative 5. So we distributed. What do you see we could do next? Kiki. Yes, let's combine like terms. Now, guys, here's where we need to make sure we're paying attention. What's 3x minus 4x? Good job. Negative 1x plus 3 greater than or equal to negative 5. If you wrote negative 1x like that, is that okay? Yeah, it's the same thing. And you know what? I'm actually going to leave it like that for right now, and you'll see why in a second. Next step. Brianna, what would you do next? Okay, so negative 1x is greater than or equal to negative 5 minus 3 gives me negative 8. Yeah, my number line's not going to work here. And then, guys, here's where students stop because they think, okay, I have negative x greater than or equal to negative 8, done, because I got x by itself. Technically, is x by itself? No. No, Jen, why not?
Because it has a negative 1 attached to it.
Yeah. I was going to highlight it. Hold on. It's fine. It has that negative 1 attached to it. So it's not by itself. If I didn't have the 1 and I just had, negative x, did I still isolate the variable? No, because that negative 1 is still there. Okay, it can't be negative. You have to have the x positive. So if I have negative 1 times x, David, how do I get rid of that negative 1? Yeah. We divide both sides by negative 1. And watch what happens. That gives me positive x on the left, which is what we want. Okay? So this is how the top part is reading. The opposite of x is greater than or equal to the opposite of 8. What's the opposite of negative x? Positive x. What's the opposite of greater than or equal to? Less than or equal to. And what's the opposite of negative 8? Positive 8. Okay? Another way we can look at this, negative 1 divided by negative 1 is positive 1. Negative 8 divided by negative 1 is positive 8. But since we changed the signs of everything, we have to change the way the inequality flips. Okay? So my answer should actually be x less than or equal to positive 8. Now on my number line, I totally did not have those right numbers. So let's kind of fix it. So I'm going to do it the way that you guys were talking about. So we're going to have 8 in the middle. What's one number bigger than 8? 9. What's one number less than 8? 7. And then, because I like having more numbers in there, I'm going to write them in. You do not have to. I just like the numbers. So less than or equal to 8. I have to put an endpoint at 8. Is that going to be closed or open? Closed. And where are the numbers less than 8? If I go to the left, are they getting smaller? Or if I go to the right, are they getting smaller? To the left. Okay. Recording. Jen said, if the x is on the left side, it will always be whatever direction the inequality is pointing. So this inequality in this problem is pointing which way? To the left or to the right? To the left. Come on. And all my numbers are going to the left. So then my question is, what if I had the inequality x, or actually let's do 7 greater than x. This time, that is actually greater than, not another 7. Yeah. Greater than x. Could I rewrite this?
Yes.
Yeah, because look at this. What is this saying? Is this saying that 7 is bigger or that x is bigger? 7 is bigger, because remember the alligator? Always eats the bigger number. There's your little, here, can we draw the little eyeball? Okay. Our alligator is eating the bigger number. So, what is an inequality that is equivalent to this? Jen?
X is less than or equal to 7.
Well, there's no equal to on this one, so you can't add less than 7. Is the alligator still eating 7? Yeah. There's his little eyeball. Okay? So we can flip the whole thing as long as the inequality is still opening to the larger number. Does that make sense? Okay? So I always suggest that we get x on the left-hand side because it just makes more sense to read it that way too. X is less than 7 is a lot easier to understand than 7 is greater than x. You see what I'm saying? Okay, so that's just something that I want to make sure that you are aware of for your kind of number sense sort of understanding of inequalities. Okay? So example 4 has 2 parts. We're going to do part A first. 10 minus 8a is greater than or equal to 2 times the quantity of 5 minus 4a. What would you do to start? Who wants to help me out? Christian. Distribute on the right. So that's going to give me 10 minus 8a greater than or equal to 10 minus 8a. OMG. What happened?
Identity.
It's an identity. Why, Jen?
Because if you keep solving, they will equally.
Yeah, guys, is this going to be always true no matter what?
Yeah.
Yeah, because of the equal, right? So how many solutions are there here? Infinitely many solutions. Okay, because it's the identity. So identity is another way of saying that. You could stop here. No, because there's no way to draw it. Because eventually, if we cancel everything out, we're going to get 10 is greater than or equal to 10. So basically, a dot at 10. So there is no way to draw it on the... I mean, there is. We could just draw the number line. There's 10. 10 is always greater than or equal to 10, so we just put a dot at 10. That's really how it would be drawn on the number line. Okay? What if I didn't have the equal sign and I just had 10 is greater than 10? Is that possible? No, so that would be no solution. Okay, so having the equal sign underneath is super important because 10 greater than 10 is not possible because they're equal. Does that make sense? I think, though, if it ever comes out this way, it will always have the equal sign. But let's take a look at B. So B, 6m minus 5 is greater than 7m plus 7 minus m. AJ, first step.
We could add minus m. Right?
Okay, so he wants to do plus m to both sides. That will work. It's a little bit of extra work. Faith, do you see something we could do instead?
Add or subtract 1m from 7m.
Yeah, we can combine like terms first. What your way is totally still valid. I think you would end up doing more work though. Okay, so that's going to give me 6m minus 5 greater than, guys, what's 7m minus 1m? 6m plus 7. Uh-oh. So then if we did AJ's next step, I would subtract 6m from both sides, right?
Yeah.
If we're going to continue on. And what do I get? Negative 5 greater than 7. True or false? False. Negative 5 is not greater than 7. Negative 5 is less than 7. So, what do we say here? No solution. You do not have to write the words no solution. You can also use the circle with the line through it. They mean the exact same thing. Sound good? What if the answer came out to negative 5 less than 7? Is that true?
Yes.
Is it always true?
Yes.
So that would be infinitely many solutions. Okay, does that make sense? So if it's a true statement, it's infinitely many. If it's a false statement, it's no solution. Okay, so let's actually write that in our notes. So the infinite or no solution is a false statement. I don't think that's going to fit. False statement, infinitely many, or identity would be a true statement. Okay. Always. So if your variables end up canceling out and it is a true statement, infinitely many solutions. If the variables cancel out and it's a false statement, no solution. And that's true for equations as well. Okay? Last problem. So, example 5. You are building a fence against a wall that has a width of 12 feet. You have at most 42 feet of fencing. What is the maximum length you can make the fence? Yeah. It's only 3 sentences. So, here's my wall. Let's make it red because obviously it's going to be a brick wall. So here's my wall. Like the wall is going up and I'm using part of the wall as the back of my fence. So it would be like okay, so that's my wall. Okay, so it's like if I was saying against this wall right here, I wanted to build a fence, so I'm going to use part of the wall as my side. So my fence is actually only going to be covering 3 sides of it, right? And we can assume, actually let's make it a little longer. We can assume that this width is the same width as the wall. So this is 12. Okay. So if the width of my wall is 12, that means this part of the fence also has to be what? So 12 feet. And so I don't know the length, so I'm going to label it L. And I like to use cursive L's when I'm talking about length because then it doesn't look like a 1. Okay? So let's talk about this problem and what we have and what we still need. So if I am building a fence, that means I'm using what type of measure? What? Feet. Am I finding the area, the perimeter? What am I looking for? Perimeter, which means I'm going to add everything together, right? Now, do I have to include the wall part? Am I actually putting fence against the wall? No. So how I'm going to have L plus what? 12. So that's all the fenced part. And I have at most, and this is where students get confused too, so make sure we're actually thinking about the problem. At most 42 feet of fencing. So does that mean the amount of fence that I use have to be less than or equal to 42 or greater than or equal to 42? Less than or equal to 42. Because I cannot exceed 42 feet, right? Okay, the rest of this should be pretty simple. Yeah? Finish it on your own, please. 15. So Isabella got length, I'm going to write it over here, is less than or equal to? Less than or equal to 15 what?
15
feet. Thumbs up, you agree. Thumbs down, you disagree. Excellent. Good job. Okay, guys. That's inequalities and solving them. So make sure that you are doing questions and a summary for me. And then please note what your homework is tonight. We'll correct it tomorrow.